Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, this week, it is a pre-recorded session. So if you do have any questions, if you're watching on Zoom, you can reply to the confirmation email you got. That'll go to my email box, and then I'll respond to those when I get back from traveling. If you're watching this on YouTube, just leave a comment under the video. Same thing. I'll get to those when I get back. And then on Facebook, you can just leave a comment underneath as well. And then I will get to those at the end of the session as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had 30 different Snap-on franchisees I worked with, as well as the shops that they service in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So worked at a dealership, and I guess over time became the go-to diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is anti-lock braking systems, operation and testing. So we're getting to ABS. So we talked about speed sensors a few weeks ago, which is one big component of the ABS. So now we're just going to expand upon that, talk about ABS and the ins and outs of that, and also talk a little bit about traction control, vehicle dynamics, ESP, whatever they want to call it, which uses the ABS system as a component of that as well. So first off, we'll cover a little bit of history, and then differences between systems. There's a bunch of different types of systems that we can use with different number of sensors, different number of channels. So we'll talk about all that. Some component operation, we'll talk about the different components and how they work, how we would test them, and we'll also talk about some scanner functions that we'll need along the way as well. So first off, ABS. I bet you didn't know that ABS has been around a lot longer than just the last 40, 50, 60 years. It was originally introduced for airplanes in the 1920s. So they needed, after World War I, they had, I guess they must have just, that's where really airplanes really took off. No, no pun intended there. But so we could not lock up the wheels when they were landing. They wanted them to not lock up. So they had a primitive ABS system for the planes. Modern automotive systems took place late 60s, early 70s. So Ford's SureTrack system was the first mass market one. Came out in 1969, and then it was standard on all Ford vehicles in 1971. And Toyota came out with the first computer-controlled system in 1971 as well. And then BMW, for motorcycles, added it to the first motorcycle ABS in 1988. So that's a little bit more recent to put ABS on bikes. But, cars has been since the 70s, really. So really kind of just took off, and it's been standard ever since. Usually it's going to consist of 3 or 4 wheel speed sensors. There's a couple occasions where we might have less, and we're going to talk about that in a minute. But we need an electronic control unit as well. So we're going to have the computer control of it. A hydraulic pump and solenoid. So that's going to give us our pressure characteristics. And what it does is it open and closes those solenoids very rapidly. It's designed to essentially pump the brakes faster than a human to control the wheel speed. So instead of you having to pump your foot, we actually want to leave it, keep your pressure on that pedal while the pump pumps the brakes and moves the calipers in and out, as it were. Modern systems can apply and release those brake pads 15 times a second nowadays. So that's way faster than you can move your foot. I'll tell you that. So definitely used for a bunch of other applications as well. Different system types that we'll run into. So you're going to want to kind of understand how the system's set up before you go to work on it. That's always a good plan, is to just recognize what you're working on. So way back, I don't know about way back, but a ways back, we were left with one sensor, one channel. So they had one speed sensor on the vehicle and it was on the back axle, and then they would control the rear wheels with the 2 rear wheels being applied at the same time. So they had a T in the line. So it's one sensor, one channel. Rear brakes, one sensor. Then we have 4 sensor 2 channel. So the early automotive system they used. It operates the front and the rear separately. So each wheel has a sensor, and then your front wheels are tied together and your back wheels are tied together, and it would operate them independently of each other. Then we have 3 sensor 3 channel. which would be on trucks with three wheel speed sensors. So you have 2 on each wheel and 1 on each wheel in the front, and then 1 on the axle in the rear. And then you would have 2 independent front wheels, and the rear wheels would be tied together with the brake lines as well. And then we have 4 sensor 3-channel. So 4 sensors, 1 on each wheel. And then we have the front wheels are independent, 2 channels there. And then the rear wheels are tied together again. And then we have 4 sensor 4-channel, which is where all 4 wheels are independently actuated and independently monitored with the sensor. So that's by and large, that's what you're going to see nowadays on most modern vehicles. It's going to be 4 sensor 4-channel. I'm sure there's some 4 sensor 3-channel models still out there. I'm sure some of them will still come in the shop that are the different styles as well. But as I said, most manufacturers have gone to a full 4 sensor 4-channel setup just to give them better control over each wheel. We talked in our speed sensor class about how speed sensors operate. And if you want more information on that, you can go check that out. Previously recorded a few months ago, but there are a few weeks ago. There are 2 different types of speed sensors. We have our passive sensor and we have our active sensor. So on the passive sensor, the sensor is a magnet. It's an electromagnet. It has a coil of wire around a central core, and it generates a magnetic field with this metallic rotor spinning on the wheel. It disrupts the magnetic field and generates a voltage and sends it out to the computer. Whereas on the newer style, the active style, it's going to have these magnetoresistive elements in here, in this case 2, and it goes into a integrated circuit, and then it sends a signal out to the computer. Now, these don't have a very large voltage that they output. It's actually very, very small voltage, and the computer is able to pick up on the differences in the voltages, and that's how it's able to calculate the speed. Also with these, or how these work, is we have this ring that's built into the wheel. Usually it's in the wheel bearing hub assembly. And you see we got north and south poles all the way around. So these little magnets in the inner bearing race. And as that spins around, this sensor sees the magnetic field going by, and it generates that signal. Manufacturers can also use that to detect the direction the vehicle is traveling in. So in this case, if we're going forwards, the north pole hits the A chip first, then hits the B chip or sensor. So if A goes up first, then it knows that it's going forward. If it goes the other way, B goes up first because it's going to hit that, the magnetic field is going to hit that B first going the other way. And that goes up like that, and it outputs a modified square wave when it does that. So why would a manufacturer want to know which way the car is going? Well, if I'm going forward and I need to apply the brakes, I need to apply more brakes to the front because that's where the weight is going. If I'm going backwards, then I need to apply more in the back because that's where the weight's going. So they can proportion the brakes depending on where they're needed the most. So that's with the direction detection function of that. So here's just an example on a GMC Acadia. So wheel speed sensor is a 12-volt digital sensor. The electronic brake control module sends a 12-volt reference voltage signal to each wheel speed sensor. As the wheel spins, the wheel speed sensor produces a square wave DC signal voltage. The wheel speed sensor increases the signal frequency as the wheel speed increases, but does not increase the signal amplitude. So since it's digital, the square waves will get closer together. The faster it goes, the slower it goes, they'll get further apart. They won't get any taller. They won't get any shorter like an analog signal. They'll just get closer together or further apart. And then it says they're at each wheel hub or suspension or steering knuckle assembly. So they're mounted to the wheel. And then since we're in guided component test here, we can see the wire colors as well and what view we're seeing of that. If we go down a little further, here's our test. Lab scopes should be used to check for waveform signature integrity. As the wheel RPM changes, the frequency will change. As it says, it'll get closer together. And you can see it's not a huge output. It's like a volt. So 0.6 of a volt to 1.6 volts almost. So it's about a volt is what it puts out in this case. It's not putting out a ton, but it's set up to show that. Also to note with these, and this isn't just for GMCs, but GM decided to put out a bulletin on this. On some vehicles, the following C codes may be set: 0035, 40, 45, and 50. In addition, the following lights may be illuminated: ABS, service traction control system, and or service stability track, which is what they call their stability. This may be caused by bits of ferrous magnetic debris stuck to the wheel speed sensor magnetic encoder ring. So as we said, that encoder ring is a magnet with north and south poles, And any metal we have going around underneath the vehicle, maybe got some rust. That never happens underneath the car, right, on the chassis. So yeah, rust, dust, and whatever gets on it, it can mess it up. So if experiencing these systems, the ring may be cleaned by using a soft nylon bristle, toothbrush, or equivalent. Don't use a brass brush. It's also important not to use any kind of magnetic tool to remove the debris, or you can damage the encoder. So if I figure, I'll just magnet all this magnetic material off, well, it could mess up the encoder and mess up the magnetic field with those. So we don't want to do that either. So just be aware. And then here's just a GM's graphic example of what that might look like. So here's all our shavings, iron filings, whatever you want. And then there's my encoder ring on the outside. So it might get stuck to it because everything there is pretty much magnetic. Also, Volkswagen Passat, I found this TSB. We'll actually pull up the whole TSB when I go live on the tool in a few minutes. This is on 2012 to 2015 Passats. And on those, apparently, you can't swap sides. So the speed sensor is the left speed sensors for the left side and the right speed sensors for the right side. They are keyed differently. They're set up differently. So if you swap them, they get too close to the ring and it wears it right out. So you can see it's all wore out there, and you can see where it's all worn out, right? And then here's just another example of one of those types of sensors. In this case, as the wheel spins, the sensor will produce a square wave that varies by about 400 millivolts, cycling between 10.4 and 10.8 volts. And the meter sets itself up to focus on that pattern. So if you look here, it goes like -2 to positive 2.2, -0.2 to positive 0.2. So that's 0.4 of a volt overall. So 400 millivolts. So it's set up with AC coupling. So it centers it on the screen, and it amplifies the differences between the two. So we can actually see that. So this one was spinning by hand. So it looks a little jumpy here every once in a while. But that is on a Chrysler Dodge. I'm not sure. We also have the hydraulic unit. So it's essentially 3 pieces. They're usually integrated now. Sometimes they can have a separate module, but usually they're integrated now. We have our pump, and then we have our basically the solenoid packs and the accumulators there. And then this over here is going to be the ECM with the coils there. So these are solenoids that are open and closed, and we'll see more about how that works in a minute. But that is where all the solenoids live. And then they're attached. These go inside over here. And here it is kind of assembled minus the ECU on the other side. So you can see the accumulators and all the different solenoids that it uses to open and close the passages for the car. You can see it is 4 channels too. It's got 4 screws on the top for 4 brake lines. So how it works, essentially how it works. We found this animation on YouTube. And under normal braking, it's going to apply the brakes. And then if the computer notices the wheel is slowing down too much, because this is the wheel speed sensor, it's going to energize that solenoid, and then it's going to make it open or pull it up anyways. And it's going to close off that the brake fluid there. So it's going to maintain the pressure on the wheel. If the wheel continues to slow down with the pressure being remaining, it increases the amount of current flowing, turns on the pump, and then it opens up the solenoid even more. So then it can now allow the brake fluid to flow backward. So it's going to reduce the pressure off of the back of the brake pads. So that's the feeling you feel in the pedal when you're holding on to the pedal to stop the vehicle. So if you're going like that, that is the fluid going back into the master cylinder. So you actually feel it just kind of filling up a little more. And like I said, it can happen 15 times a second now on a modern vehicle. So 2-stage solenoid closes it off to maintain and hold pressure. It'll build up pressure going through here. It'll maintain pressure by closing that, and then it will relieve pressure by opening a second time. So that will allow it to do its 3 functions. That's the 3 main functions of the ABS. Build up pressure, hold pressure, release pressure. And there we go. So that brings us to traction control and vehicle dynamics as well. So it uses the ABS system, as well as additional sensors and additional parts of the vehicle, as we'll see here in a minute. But the main sensors that we're going to use to go with that is going to be yaw rate sensor or multi-axis acceleration sensor. So it knows which way the vehicle is going in space. A steering angle sensor, and perhaps a steering effort sensor as well, plus other sensors that we'll see here in a minute. And what it does is it modulates the braking to gain traction on slick surfaces. So if my wheel starts to spin, like in snow or sand or trying to do a burnout, it will apply the brakes and slow down the wheels from doing that. Modulates the braking to control the vehicle skidding or from the wheels to spin when we don't want it to. Now, also with the traction control, if you're trying to test a vehicle up in the air, like trying to do a wheel speed sensor or something like that, and it has traction control, you want to turn that off. Because if you try to turn the wheels up in the air with the car running, the computer is going to think, oh, well, the wheels are slipping because they're continually spinning in the air. So the wheels must be slipping. So I'm going to apply the brakes. And then it throws everything out of whack. So we got to make sure we turn that off. There usually is an off switch on there, traction control off or vehicle dynamics off or whatever. So here's back to the GMC there. And they give you a little overview of how it works. So this vehicle is equipped with a TRW EBC 460 brake system. The electronic brake control module and the brake pressure modulator are serviced separately. So that means we can change out the computer if we need to, or we change out the hydraulic unit if we need to. The brake pressure modulator uses a 4-circuit configuration to control hydraulic pressure to each wheel independently. So this is a 4-sensor, 4-circuit vehicle. Depending on options, the following vehicle performance enhancement systems are provided. So we have ABS, traction control, stability control, dynamic rear proportioning, where it changes the proportioning of the rear brakes. Hill descent control system, which will actually apply the brakes as you go downhill. Hill hold start assist, which will actually help you when you're trying to go uphill, when you're trying to start on a hill. Keeps the vehicle from rolling back. Cornering brake control, hydraulic brake assist, optimized hydraulic braking system, intelligent brake assist, trailer brake control system, and trailer sway control, which is all kind of using that ABS. The following components listed are involved in the operation of the brake system. So I scroll down a little bit. Electronic brake control module controls the system functions that detects failures. Applies voltage to the solenoid valves and pump motor. The modulator contains the following components, which is the pressure sensor, hydraulic pump with pump motor, 4 isolation valves, 4 dump valves, 2 traction stability control supply valves, 2 traction stability control isolation valves, a high pressure accumulator, and a low pressure accumulator. Body control module is also involved. It monitors the brake pedal position sensor signal when the brake pedal is applied and sends a high-speed serial data message to the electronic brake control module indicating the brake pedal position. So it is not a brake light switch anymore. Sometimes the brake light switches are part of it, but it is a brake pedal position sensor. So it's kind of like, it has that plunger and it's able to see, kind of works like an accelerator pedal position sensor, except it's not a swing. Brake pressure sensor also is there, used to sense the action of the driver application of the brake pedal. The sensor provides an analog voltage signal that will increase as the brake pedal is applied. The electronic brake control module monitors the brake pressure sensor, which is integral to the brake pressure modulator. The instrument cluster, that displays the vehicle speed based on the information from the engine control module. So that it gets the engine speed or the vehicle speed from the wheel speed sensor. The yaw rate, lateral acceleration, and longitudinal acceleration sensors are combined into one multi-axis acceleration sensor, which we're going to talk more about in a minute as well. And that is actually internal to the inflatable restraint sensing and diagnostic module. So that's the airbag module in the middle of the vehicle. Electronic brake control module receives serial data messages again. Multifunction switch to turn it on and off. Steering wheel angle sensor, so it knows what the intended driving direction is for the vehicle, and that is internal part of the power steering gear on this vehicle. Transmission control module, because it needs to know what gear it's in, and it'll help out with hill start assist or hill hold. And then active wheel speed sensors as well. So we talked about that, how the frequency of the square wave is going to use to calculate the wheel speed. So a lot of stuff going on in these systems. It's more than just the pumps and the solenoids and the valves and everything and the wheel speed sensors. Now it is a lot more sensors and a lot more modules, and we got a lot of serial data going on, as we'll see when we look at some of these sensors. It's mostly network information now. It's not just a direct line. And we'll see that when we go live on the tool. So we talked about the yaw rate sensor. So what is yaw? Yaw is this way when my car is going this way. So usually the sensor is fairly central in the vehicle. It's at least in the center console, if not try to even get it centered front to rear. Yaw rate sensor, inclinometer, longitudinal and latitude sensor, whatever you want to call it. It's so the vehicle knows, or the computer knows, where that vehicle is angle-wise in space. So look at the 2011 Subaru. That has a yaw rate sensor in there, G sensor as well. So the yaw rate / G sensor detects changes in vehicle direction. Detects the motion by moving electrodes built into the sensor. The sensor will send ABS control unit a signal by the change in voltage. And then it just sends it over the CAN line. So it doesn't even, once again, it doesn't have a signal wire, it sends over CAN. So it's in the center console next to the parking brake assembly. So once again, centrally located in the vehicle. And I can test for ignition power, and that's really it. I can see if there's network communication going on, I guess. That's about it. So it tells you to check the output of the sensor with the scan tool. You can only look at the data with the scan tool. With the yaw rate and G sensor installed, the value should read -4 to 4 degrees a second on yaw rate, or -1.5 to 1.5 meters per second squared on the G sensor. On both the yaw rate G sensor to angle 90 degrees forward, and then rearward, and then to the left and to the right. So you just kind of pop it on around each angle, and the sensor should read 6.8 to 12.8 meters per second square. So just judging on where it is. So if it doesn't receive that data point change, then either you have a bad sensor, it's not sending data. Here's a multi-axis acceleration sensor on that GMC. So we have, once again, it's a CAN bus circuit. The EBCM receives serial data inputs from the yaw rate, longitudinal, and lateral acceleration sensor. That's once again in the passenger compartment under the floor mounted center console. So it's right in the middle, underneath the attached to the brake airbag module. Multi-axis acceleration sensor output signal is part of serial data. If power and ground the sensor are okay, check the signal circuits for high resistance, open or short to ground or power. A DTC may be set indicating as well. And really the only test we can do is a voltage test. So we're going to see if we have, at least battery voltage at the sensor on the supply voltage line, and then check the ground, make sure that works too. Steering angle sensor, of course, tells the computer, which way am I steering? How many times have I steered around? So what angle should the wheels be in if everything's going the way it should? So steering angle sensor, sometimes it's up by the steering wheel itself in the clock spring. Sometimes there's two, sometimes one at the top and one at the bottom. A lot of your electric racks are going to have them integrated in there as well. And then sometimes they also have a torque effort sensor, so it knows how hard you're steering as well. So if you take that into account, I'm still steering really hard left, then we need to know to correct that way in order to keep the car going down the road safely and straight. So, all right, let's walk through on the tool a couple things. Okay, so first thing I want to talk about is inside guided component test. So if you have a Zeus or a Verus or a Verdict or a Triton or a Modus or a Vantage, you will have these guided component tests in their information that's in there. So one thing that we do is these classes. There's over 65 categories of class in here. On the latest software update, it's on the top. Sometimes it's on the bottom if you're a little out of date. And if you're way out of date, then it could be a totally different button. But you definitely want to stay up to date because you might not even have some of these classes in there if you're not updated. There's power user tests, features and benefits, and how to, and the classes are in there in the how to section. So you can see there's a lot of stuff going on. But where I want to go, the first 20-minute class, 20-minute anti-lock braking class. System operation, basics and fundamentals, testing active and inductive wheel speed sensors gives us a choice on those as well. So if we go into system operation, it's going to tell us the different, what it needs to do. So increase pressure, maintain pressure, and reduce pressure, like I said. So that's how it's going to work. It's going to walk you right through it. You can read it yourself when you have time. Testing active wheel speed sensors, that gives us that square wave. And then testing inductive wheel speed sensors is more of the analog type. And you're going to be able to see the difference between those two types of signals. So that is built-in training. If you want to take more training or want a refresher on what we're talking about today, that's a good place to start. All right, first one I want to go in is this Passat. All right, we talked about that. Let's go into shop key and see what information we have. Okay, so this is where I found the TSB. So we're going to go into TSBs and we'll go to brakes. Go. And then there is my bulletin right there. And this is a bulletin right from Volkswagen. It is a tech tip, actually. So 2012 to 2015 Passat, Jetta, Beetle, Golf, Tiguan. ABS and TPMS light is on due to wheel speed sensor fault as a result of the front wheel bearing wheel speed sensor swapping. So if we're doing Swapognostics and we're trying to swap it side to side and see if the problem follows, we don't want to do that with these vehicles. It can be due to the encoder ring being ground down on the wheel bearing hub unit, resulting in a damaged part. Damage from swapping speed sensors left or right during diagnosis. And then we can see how the encoder ring is damaged. We can zoom in on that if we want. It's kind of hard to see, but it's really worn out in there. These are red circles they drew on it, but you can see how it's wore out there in the middle. And then same thing with the sensor. And it says, tip, discontinue the practice of swapping sensors from side to side during workshop diagnosis. So you did a thing and it broke it, don't do the thing. That's basically what they're trying to tell you. Don't do this because it breaks things. So make sure if you're on one of those vehicles that you don't do that. Good to know. Okay. So now let's go guided component test and see what we have for the ABS. Got the module, got location, pinouts. It's going to give you all the pinouts there, what you need to know. We got system descriptions, going to tell us how it works. Also has electronic stability plan. Brake light switch, in this case, it is a switch. So we have a switch signal to ECM and a switch signal to BCM. So it has two different ones, and it's also connected to the CAN bus in there as well. Signal to vehicle electronic system module goes in there as well. So all of that runs over data lines. Brake pedal switch is attached to the brake master cylinder located on the left side of the vehicle attached to the brake booster. We have a CAN bus test in there because a lot of the stuff operates over CAN. We got ground and we got power and wheel speed sensors on here. So let's look at those special wheel speed sensors. It's a Hall effect type switch that measures vehicle speed by measuring a reluctor wheel located at each wheel. As the wheel spins, a digital square wave signal is produced. There's no separate signal wire. The signal is superimposed onto both signal wires. Signal frequency will increase with an increase in wheel speed. The ABS module uses this signal as a vehicle speed input, and by monitoring the wheel speed sensor signals, can detect wheel slippage. The signal may also be used for cruise control. So that gets a speed on that. Sensors are often out of position due to previous repairs to suspension or brake systems. Also check for poor terminal connections at the connector. And we can see the connector views right there. And don't swap them side to side as we saw in that bullet. Okay, next one, we're going to go with the Nissan Murano here. And what we can test here is we got the module again with pinouts. Always good to have pinouts. I did a lot of wiring work back in my Subaru days. So having the pinouts is very, very helpful. Chase the wires. Stop lamp switch on this one with a vacuum sensor, though. This one has a vacuum sensor to tell on the brake vacuum booster to see how much vacuum there is. This is just a standard pressure sensor, so 5 volts, power, signal, and ground. So very simple. DC voltage change with increase or decrease of vacuum. Also on the wheel speed sensors, I think these are the same thing, right? Yep. Hall effect switch measures the vehicle speed by measuring a reluctor wheel, digital wave, square wave. No separate signal wire. The signal superimposed on the ground wire. And it tells you the locations and it gives you the pin assignment. And here's another one. Metal debris and loose sensors can cause an erratic signal. Harness is easily damaged during brake service. So we want to make sure that doesn't happen either. And then the last one we'll look at is Tahoe 2018. So that's got a brake booster vacuum sensor. It's got a brake fluid level switch, the CAN bus, parking brake switch, multi-axis acceleration sensor, wheel speed sensor, steering angle sensors, powers, grounds, electronic brake control module pinouts. I want to look at that brake pedal position sensor. The engine control module monitors the brake pedal position sensor and other sensors to determine if reduced engine torque is needed to assist in lowering vehicle speed. The brake apply sensor is in the same housing and is for the body control module to turn on the brake lights. So it has 2 sensors. One goes to the BCM for the lights, and one goes to the computer to know when the brakes are being applied. Both the sensors work the same way. When the pedal is released, the voltage would be about 1/4 volt, and with the pedal fully applied, the voltage would be about 4.75 volts on the signal wire. So we have two sensors, low reference, 5-volt and signal on both sides, and then we'll be able to see, you'll be able to pin out any of those and see, do I have 5 volts, do I have ground, and do I have signal on? So it's under the driver's side of the instrument panel, connected to the brake pedal, go figure. Also with this though, also with this vehicle, I learned something the other day. I never really thought about it much, but somebody asked me the question and we figured it out. So on this truck and many GMs apparently, when you replace that brake pedal position sensor, you need to do a relearn on it, and you need to just relearn it in 2 modules. So you need to relearn one in the DCM and then one in the brake control module. Now, if you didn't know that, you might miss one. Also, you're going to have to hunt around. You're going to have to go into this module and go through the functional tests or output controls and try and find it. And then the same with the other module. Or if you have one of the tools that has the service resets and relearns quick menu, this is where it's going to help you out. So if I go down here to my brakes and I see replace or relearn brake pedal position sensor. So I can go in here. It's going to give me top repair data. It's going to give me TSBs, if any. And then if I click on this functional resets and calibrations, it actually pulls both resets from both modules. So I have one here, I believe that one's for the engine, and I have one there that is for the body control module. So if I go in there, I'm going to hit learn on the next selection. We leave the brake pedal sensor up, and then we hit learn, and then procedure's done. And then we go to this one, do the same thing. Start the learn procedure. Just like that, a little bit more data on this one. And there we go, test complete. Very, very simple, but you need to do it after you do the brake pedal position sensor. And if you didn't know you needed to do that, you could miss it. And maybe you only do it in one of the modules instead of both of the modules if you didn't know you needed to do it in both of the modules. So I think that's pretty cool. That's how it works. It just kind of brings everything to you on the screen instead of just having to go into separate modules. So I thought that was a huge time saver that you might like to know. You can do the same thing with the yaw rate sensor too. You can go in and make adjustments on there as well. That's just one. But we can go in there and relearn the sensor. Flat level surface, remove all excess weight, and then it's going to recalibrate itself. This one might, no, it works. Procedure complete. That's a very simple one too. So if I have to do a multi-axis sensor, if I have to replace that, that's pretty simple to do. So with that, that's my time. Let's talk about next week. So next week we're talking about driver comfort systems, operation and testing. So you might be, well, what is a driver comfort system? So I'm using this as a catch-all of kind of things that you don't really need in a car, but they're there for your comfort. So heated and vented seats, don't need them, really nice to have. Heated steering wheel, same thing. Noise canceling systems. I don't want to hear the sound of the road noise. I don't want to hear the sound of my car. So they send out sounds to cancel the noise. Sound generation systems. We've mentioned it a little bit in like EV and hybrid vehicles. They make sounds, so you know they're coming. Electronic motor mounts. Those have actually been around for a while. Those have been around for, geez, I don't even know, like probably I think since 2010 or so, maybe even earlier. But if you have some sort of an engine vibration running problem, if you don't turn off the electric motor mounts, which we'll talk about, it's going to be hard to diagnose a rough running vehicle with that off. So all sorts of weird things you might not even ever thought of belong in a car or in a car. We'll talk about quite a few of them next week. So same time, 6 and 9 Eastern. If you want to join on Zoom, go to snapon.com/OT, register there. Otherwise, the 6 p.m. Eastern goes live to YouTube, youtube.com/SnapOnDiagnostics. And then the 9 p.m. Eastern, like we're doing right now, goes live to my Facebook page. So it's facebook.com/SnapOnJason, all one word, no dash in the Snap-on. If you give me a follow over there. If you prefer to watch on Facebook, you can do that. If you prefer to watch on YouTube, you can do that. or if you prefer to be on Zoom, you can do that. We try to give you as many options as we can to get this free weekly training. If you want to see any of our past prior topics that we talked about, like ADOS or data bus testing or variable valve timing, all of those classes are available on our YouTube channel as well. Go to youtube.com/Snap-on Diagnostics. And then there is a separate playlist for live training. And with that, we're up to Q&A. Now, as I said, this is a pre-recorded session this week. So if you do have any questions, if you're watching on Zoom, just reply to the confirmation email. That'll go to my email inbox. If you're watching on YouTube, just leave a comment under the video and we'll help you out when we can. And then same thing with Facebook, leave a comment under the video and I will get to those as we go throughout. Also want to make sure I mention my buddy Al, who also does free diagnostic training. He does tool-specific training. So if you want to get a little bit more knowledge as to what your tool can do, how it works, Monday it's on Apollo, Wednesday it's on Zeus, and Thursday it's on Triton. So very thorough class all the way from let's make sure your Wi-Fi is set up. Make sure that's all set and going because a lot of features on the tool actually need Wi-Fi nowadays. And that's through the manufacturer even. All the way through, let's set up your free Snap-on Cloud account so you can upload and share files. And then we'll go through code to completion, fast track intelligent diagnostics. How does it help me as a technician diagnose vehicles faster? And then that's about an hour long for all that. Each night, depending on what tool it is, he'll just do it on the respective tool. Wednesday and Thursday, though, since those tools also have scope and meter functions, take a 5-minute break after that first hour. And he goes through another hour on the scope and the meter and real world examples of where he would use that and what it would look like, fuel pumps, things of that nature. So same time, same place, Monday, Wednesday, or Thursday, pick your tool, snapon.com/OT. He only goes to Zoom, so you'll need to be, it's more of an in-person type session. Your camera's not on, but he'll be able to answer your questions. You type them in the Q&A. He's definitely able to answer your questions live, and it's kind of designed to have the tool in front of you following along with what he's doing on the screen. So once again, go check him out, snapon.com/OT. It's free. With that, thank you very much for your time today. Thank you for taking a little bit of time out of your busy week to come join us. Thank you very much, and we'll see you next week. Have a good night.